T2 demos. T2 demos. T2 demos. This is the first test to try to do time-lapse with the X-T4. There's the parameters. We're going 300 times. Speed up, these are JPEG frames. There's lots of problems with this, but it's fairly encouraging. I'm worried, since this is just one power zone, I'm worried about when we get to like 9 power zones, whether there's going to be enough res. But we'll see in the second demo where I do some camera projector automation, I'm calling it, that it looks pretty good. We can push from here, we can push all the way into a single tile after the fact and still like read the text, for example, which was not really true with the previous solutions. I don't know if that will still be true with 9 power zones, but we'll see. So this was a big update of almost everything, because I hadn't had this grid fired up for quite some time. I'd been working on the single ring, and then obviously just doing a Hugene run, which I wanted to run until it settled one way or the other all by itself, but I didn't really understand how the Fuji X-T4 works, and its battery died. So that's where this simulation ends. All right, so here we are pushed into a single video, also with a little bit of color grading, since the background of the CDM menus really should be brown. And the LCDs we're using are really so low quality. So I've just tried to get this to approximate, to sort of emphasize rendering what passes for true colors on the LCDs, and let the the T2 tile cases and the surrounding environment and stuff go hang. But I'm also, and this is using the Kdenlive transform effect with keyframes that are set to smooth, which is cubic splines, I think, and I'm starting to get them working. You can see that this is actually fairly smooth, and it doesn't have a lot of changing in directions that don't make a certain amount of sense given the action on the screen. So this is it. This is the first test. I've now got an order for one of these dummy battery things that connects to a charger so that it's not relying on USB power. So hopefully we'll be able to do much longer. Lots more stuff to do. Just figured I'd put the first test up. That's it. demos. I mean, like, that's the ancestor of the Diamond Grid, the HC3 grid, before it had any cell membrane, and it just had some kind of random swamp worm flailing around in it. Made some progress. Oops, I guess our startup video ran a little short. We'll get a new one for next time. Hey folks, welcome to the Artificial Life Advanced class. Good news, everybody. Things are better. Let's start by taking a look at what's been going on the T2 tile grid for the last 10 days or so. Had a new engine getting distributed along with new physics. So there's a bunch of different things here that are important. I'll talk about some of it afterwards. The contact warnings when the diamonds are bumping into each other or bumping into the edge of the universe, they've been toned down to make it easier to see. So there, for example, so right in there, that used to be much more blurry, but it's following the same old pattern, right, where I when I first design something, first get it running, it's taking up all kinds of screen real estate, but as I move on, everything that used to be all over the place gets smaller and smaller and smaller, because I want to have visual space left for whatever is actually new. And what's new now is the loops in the around the diamond sequencer. But this is running quite quickly by T2 tile standards, and it's been running solid. It's been running for 10 days or something like that. I'm going to let it keep running until it stops running by itself, unless I get much better code. I'd like to let it run for another maybe a week or so. We'll see. But this is encouraging, and this is part of the reason why things are better. So, all right. And the main point is, yeah, it's still alive. That was yesterday, but it's still alive today. I just checked. So the goals for this time, for today, was self-copying program, loads and runs. Did not achieve that, but there was progress across the board, and that's why I'm feeling pretty good. So the T2 grid speed up, that's what we were just seeing. In addition to, tweaking the graphics and so forth, I made an incredibly simple change that made a huge difference. And this is it. Can you see it? This little 3-line function took the first line and made it the last line, and it made a huge change. So what this is, the whole MFMT2, the engine that performs all of the sequencing and the running of the events and all that stuff on the T2 tiles, is based on a priority queue, a time-based thing, so that whenever it finishes doing whatever it was just doing, it goes and finds the thing that has the earliest deadline, the thing that most wants to go, either the thing that's nearest in the future or the thing that is in the past if we have overrun our time. And then we call it, and the on timeout method is what gets called. And so what this does is, the first thing it does is it puts itself back on the time queue, the TQ, for redisplay Ms in the future. Now, in this case, it was a sixth of a second. So I was doing 6 frames a second, and then I check for touchscreen input, and then I redisplay everything, and then that's it. And then we go on about other business, like, for example, performing events on the sites of the grid. But as we got more and more custom graphics with the contact warnings, and then the pocket chains with their long downstream side and their short upstream side and so forth, somewhere along there, it got to the point where the redisplay function could take more than a sixth of a second. So what happens? We put it back on the time queue for a sixth of a second from now. We take more than a sixth of a second, and then we release ourselves, and we immediately are at the top of the queue again. So we just get displayed again, and everybody else who's trying to get in to do events on sites gets starved. They get an event every so often and so on. But this, I think, explains some weird behavior, one of these worries that I didn't even actually talk about, that goes all the way back, months, if not years, where every so often, especially before I got the fans going to keep everything cool, some of the tiles, especially in the center of the grid where they would get hot, they start slowing their clock down to try to maintain, to control the temperature. And sometimes, not often, I would see a specific tile that essentially was paralyzed. And, even the stuff that was moving from adjacent tiles would get stuck trying to go into this thing. And I couldn't figure out why. I suspect it may have been a problem like this. So now what I have done is I have taken don't insert it back into the time queue until the end, until after you've finished redisplaying. So this is the kind of top-down control freak, I want 6 redisplays a second. This is the bottom-up, best effort. Don't call me again for at least a sixth of a second. That's what it says here. So we do all our work, however long that takes, and then we say, okay, we have a sixth of a second to go do other things. In fact, I have now changed this to a third of a second as well, and that's what we were just seeing. And we can actually look at it. So here, I just shot it with my phone, right? And so this is real time, no time lapse at all. And we can see. You can see the HC3 grid compressions moving through the dots. You can see the loops moving around from place to place. Now, this is fast in no sense, but it's faster than it was. And you can see the new revised little subtle contact warnings there, the little orange things. And all I really need, the grid cam time lapse, which is mostly what we're looking at, takes 1 frame every 5 seconds. Redisplay Ms could be a fifth, could be 4 seconds, could be 2 seconds, 3 seconds, whatever. So this is much better. This is a long-standing anxiety of mine is eased. So great. The timeline has improved. This is what the timeline looked like last time. Didn't have state machines, didn't have the HC3 sequencer, that's what's now called the diamond sequencer. It wasn't really working, and so forth. This is what it looks, this is what it looks like today. I am calling, we have HC3 sequencer, we have state machine, got some examples. The redeploy centers we don't have yet. I'll talk about that in a minute. We're still got little bits and pieces of stuff, but this makes me feel like there's a real shot. Just getting kind of worried. The last update, the last couple of updates, the things were going pretty slow, but progress. And a big reason for that progress is because Diamond Sequencer programs are actually running. And let's take a look at a demo. Is that what's next? Yes. Okay. And so I've got this just started up. So the L1s are just seeds that place proto loops in the place, and we'll just let this go for a little while. Okay, so now 3 of the 4 L1s have popped out. So we have a marker in, so the southwest, the red diamond sequencer pocket, DSPs. We have 4 pockets. The southwest is the red one, which is output in this case. If this can be rearranged, the northwest is green, which is supposed to be input. The northwest, northeast is blue, which is temporary storage, and southwest is white, which is the execution stream. And in the execution stream, we have the loader, where the idea is the loader is going to take the ancestor code, whatever it is that's stored someplace, and as the loop in the instruction stream relaxes and gets bigger, the loader inserts the instructions for the ancestor into this primordial cell. So if we let this run a little bit, the important point to notice, it's all about bopping around and doing its thing, but the markers stay in the DSPs, southwest, northwest, northeast, and the loader stays in the instruction stream. And in fact, it's got a couple of zongs in here. That's an RS down there. That's a reset instruction, and so forth. The loader is inserting the program into the instruction loop, and none of it is executing. Why? Because the loader is hogging the DSP, the domain sequencer pocket, and it's going to stay there now because it's working until the program is entirely loaded into the loop. And it just took itself out there, and then it decayed away to an empty codon and marked the instruction stream as we have to move on to the next instruction. And that's how we boot in the domain sequencer programming language. It's actually working. So that's pretty good, and we'll see another example or two in a minute. And finally, construction arm constructed. What does that mean? Well, there's a John von Neumann, sort of father of computing in many ways. One of the many things he did was he built this cellular automata. It's kind of blocking me here. That it reproduces itself. So it's very much in the same spirit of what our artificial life creation countdown challenge that we're doing right here, right now is, except the nature of the cellular automata that we're using is very, very different. His was deterministic and synchronous, all of that stuff, because it was a proof of principle. And what we're doing here is a proof of principle too, but it's a different principle. It's the principle of bottom up, robust first, and so forth. And so the important point for this story, so this yellow line you can see down here, if you actually go to Wikipedia, it's a blue line because I've inverted all this stuff. That's the actual instruction stream. That's like sticking off hell and gone to wherever, and we're saying, no, that's not really very practical, especially if we want the entire thing to move. The von Neumann universal constructor can only move by making copies of itself. It can't actually get up and go anywhere like our cells can. That's an example of the difference in flavor, even though we're making a constructor that constructs itself. And in particular, one key step of it is that there's a tape of some kind, which is going to be the instruction loop in our system and is that big long line of states in von Neumann's original universal constructor that tell this construction arm, another automata that functions like an operating system. I don't know if that's great Wikipedia language, but whatever. But the point is the construction arm can move around and deposit stuff in various places, and that's part of, that's the main thing about how it makes copies. Sets the construction arm, goes 0, 1, 1, 0, 1, 1, and so forth. So we have a construction arm. Let's see. Here we are. Okay. This is just a minute or so. So these start out looking like, whoops. Oh, phew. Oh, all right. That's what you get for pushing the wrong button. These start out looking like what we just saw in the demo, but they're gonna start diverging in a minute, and the program is getting loaded into them, and the program is starting to execute. And look at this. These little guys here, little beings here, they head towards the wall, and they take a turn. And all this stuff is going on all at once. The thing is, the grid is growing, the grid is moving around on the larger background of events, and it's building a box. And the important point of that is that the box is largely an arbitrary shape that I just picked last night to demo. And then the cell suicides. The cell has pre-programmed cell death to leave the box behind, a box made out of wall atoms. It'll take a minute for this last being, to make its box, because in fact, it was close to the wall actually, and when you get contact warnings, it takes longer to grow and can't actually build the box until until the cell gets big enough. So look at that. And how do we do that? Here's our revised sample ancestor code, and look at that. North, west, 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 south, 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 east, 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 and so forth. Capital W means withdraw the construction arm one step and leave behind a wall atom. And dot means we're done. The program is running and performing arbitrary business, arbitrary acts. So that's what gives me hope. Controlling the pockets, chaos around, we've kind of got that. So I'm calling this the big comeback, because I was getting a little bit worried. And our three raggedy, the saddest little boxes you're ever likely to see, is the evidence of the comeback. And so that is it. The next update will not be until December. We are now entering a pre-programmed hold at T-3. The goals for then is to have proto-ancestor code running. We shall see. Publish a book. Talk about that later. I didn't write it. And I want to have big fun. And thank you so much for coming, and I hope to see you in December. Okay, and once again, I am going to take a break here and get the render started. And if anybody wants to hang around, we can talk. And if not, we'll end the stream whenever it seems like there's nothing really much more happening. But I'm stoked. Between bugs, I feel good. Okay, so I'll be back in, I don't know, maybe 10 minutes or so. I don't even know how long it takes me to do these things. And we'll see where we're at. Thanks especially for the folks who come on out for the live stream. You don't know how important you are for me to, get stoked and want to, well, I don't know if I did a good job, but get stoked anyway. T2 demos. T2 demos. T2 demos. This is the first test to try to do time-lapse with the X-T4. There's the parameters. We're going 300 times. Speed up, these are JPEG frames. There's lots of problems with this, but it's fairly encouraging. I'm worried, since this is just one power zone, I'm worried about when we get to like 9 power zones, whether there's going to be enough res. But we'll see in the second demo where I do some camera projector automation, I'm calling it, that it looks pretty good. We can push from here, we can push all the way into a single tile after the fact and still like read the text, for example, which was not really true with the previous solutions. I don't know if that will still be true with 9 power zones, but we'll see. So this was a big update of almost everything, because I hadn't had this grid fired up for quite some time. I've been working on the single ring, and then obviously just doing a Hugene run, which I wanted to run until it settled one way or the other all by itself, but I didn't really understand how the Fuji X-T4 works, and its battery died. So that's where this simulation ends. I don't know if it's worth turning the microphone on with the CPU fans while the video is rendering. But what the heck, we could let this thing run a little further and see what happens, because this actually should go all the way as well. So right now, okay, so the loader has completed, and in fact it looks like the marker, this is the opening marker, because it'll have the Dave label, is in the DSPX stream slot. So it's going to get executed. Has it already gotten executed? Yes, it already has. What markers do is they make a note to the log. They note their label to the log, so that who knows, maybe there could be a post-mortem one day. So I guess we're in the stage of heading to do bringing the reset up, and now the reset is up. And it's funny because this whole thing, look at this, reset. So here's the marker, here's the reset, here's an empty. SF, that's a shapeshifter whose job it is to try to find more room to grow the ring. And then there's a Zong. So we've got from RS nothing, Zong, nothing, constructor arm, like that. So the actual instructions are just sort of scattered hither and yon along the overall loop that makes up the instruction stream, because the instruction stream, in addition to being an instruction stream, it has to be a loop. It has to be able to move, it has to be able to grow. We'd like it to be able to shrink, but we never actually got that code working yet. I find this quite satisfying. I mean, this whole process for me is a re-education about, 6 frames a second, must go this way, towards, redisplaying is not all that critical, so make sure it doesn't happen any faster than whatever. So this reset, first what it's going to do is it's going to kill the output loop and the registers, the temporary register loop. And I think basically that's it at the moment. It used to do more. There they go. The blinking black and white loop killers. And now I think the reset is now done. It used to seed fresh marker loops in there, but I decided it would be better to leave it up to the code. So yeah, and so this is what I started to say, that even though the instruction loop is full of all of this stuff, this fluff, it's all running in parallel, and in fact, things can go zipping along and make a lot of progress, surprising amounts of progress. It's just not lockstep. It's not drumbeat. It's as possible. It's as opportunities arise. But even at, going as incredibly slow as it is, if you're going in parallel, opportunities are kind of arising in lots of places. Anyway, so the Zong does nothing except mark itself done, and so it moves on. Now we got a empty code on. All right, here we are. Boom. And now the cellular automata is running, and I would love to be able to examine the insides of it and see the program, but I never got around to actually implementing that in the MFMS. The simulator just says string. So there it is, and this is cheating in a specific way, because in Ulam, double-quoted strings are constants. They can't be modified. So the code that this CA, this constructor arm, is running off of can't evolve. We could pull it out. We could pop out the program and pop in a whole nother program, and I'm intending to take advantage of that. You can write little constructor arm programs, put one in, run it, and then put another one in. But the individual bits of it are essentially physics. They have to be recompiled to change the string. So down the road, we're going to eventually want to have something that's like a CA, but stores some of the bits that are used to determine what the constructor arm does in volatile storage, in actual bits that are mutable during events. So evolution could happen. Again, for the moment, since the construction arm instruction, on the one hand, it's this big long program, but on the other hand, it's really just a single instruction in the reset, do this, do this, do this, and so forth. I'm okay with this hack, and it got things working. And so here is our construction arm up here. Strangely, it's called a swapworm HC3 instead of construction arm, because this is what it came from. All of these, the pocket chains, all of this stuff goes back spiritually to the swapworms that we've been talking about, and you can play with an MFM.rocks, for example, for years ago. And I am now kind of satisfied and kind of enjoying the fact that have made so many different implementations of so many different things. I used to fantasize that I was supposed to be able to write this code once and use it over and over and over again, and I never can, because each new context has new opportunities and new limitations, and as a result, what gets reused are the patterns, the ideas, the ring oscillator synchronization, the stuff that's essentially leaning on each other, so that when you pull out the anchor, the root, whatever it is, the whole thing collapses away without you having to do any extra work about it. The swap worm that instead of actually moving from place to place, it essentially grows and retains control of the space behind it by using what are now called empty codons, rather than letting it be given away and have to reacquire it later. And it's the fact that we can have empty codons inside one of these loops, inside a pocket chain, that makes it actually able to be relatively efficient, that stuff can be moving all the time. Anyway, all right, and so now the look at this. I don't know if you can see it. The construction arm has a program counter. It's PC1. That means it's already injected the first program into the first instruction into the and that's what it was. It was a grow north, and so on. So we can watch this thing play out, and it's all designed intentionally. So it wants to go west 4 times. 1, 2, 3, 4. Oh, this diamond is already big enough that usually, sometimes, depending on how fast this all took place compared to how fast the grid grew, by the time it's done 3 wests, there's no complete pocket because it's at the edge of the diamond, but everything blocks. All of this is interlocked. The next instruction doesn't get injected into the tail of the construction arm until the acknowledgement from the head of the instruction arm gets back to say, yes, I did it, or I couldn't do it, or whatever. This code is very young, so there's error handling is not in very good shape, but step by step. But now I think we can go ahead, and the program counter is up to 5. It can go ahead and make the turn because the cell is big enough. Oops. And again, we've got all these shapeshifters, and we've got the kill diamond is waiting right in the wings because that's the next instruction it's going to execute when the construction arm program is done. And it's going to start heading back east, and it only goes back 3 because it doesn't want to crash into itself because that would block. But we're making pretty good progress, and it does slow down, right? Because as the construction arm gets longer and longer, the round trips to say, do this, I did this, get longer and longer, even if it's pumping in parallel as best it can on a case, available basis. And now it'll head back north 3 times, and program doing? Stay put. And I don't like to stay put. Instruction 13 in the stream. So these construction arms, given that they're just doing like macros in effect, rather than full-on things that you can think about and cogitate and decide to do slightly differently, they're quite dense. I mean, the string pool, because it is constant, doesn't take up any bits in the sites. All right, and there we go. Now it's shrunk back and left up a wall behind, and the rest of it will continue that way. And once it finally gets to that point, the construction arm instruction, all of this has been running under the control of one instruction. And again, the complementariness, the duality between traditional computing and this kind of computing, right? This is the symphony of complex instruction set computing. The CA, the construction arm, has a whole little mini language inside it to do a whole bunch of stuff. It's not one, go to the registers, read a thing, add 1, write it, and done. No, it sits there and controls a whole process. That's why I called it a diamond sequencer rather than a program, because it's not jumping all over the place. In fact, it's going to be largely linear. At the moment, it has no choice. I had started to build some skip things that would say, skip ahead to this marker and ignore everything here, so that we could start doing branching, start doing conditional code, and we'll get that going. But the spirit is much more, do this complex process. You're a supervisor. Keep an eye on things, make sure it's going, and when it's done, then pass the torch on to the next large task that needs to be done. The walls are turning in when the walls fell. I never liked that episode, actually. Here we go. And again, hopefully we'll see the construction arm relinquish the DSP, the execution diamond sequencer pocket, and it just came zooming through. That's the sort of thing that happens a lot. And there is our box. High quality. In the original box demo that I used to do, I would do 3 boxes. Well, the first one I would do by hand, just saying, pick a wall or whatever, and say, here is a box, like that. And then I would have a pre-programmed thing that would do a box once, but if you erased it, it would stay dead. And then I had the live box that you erase it and it would recreate itself. This feels like we're going full circle, because now this box that the construction arm program just made is not perfect. It's raggedy and weird and so on and so forth. But that's kind of because it was made by a living thing, just not me. Just like me doing this with the mouse is not perfect. All right, well that's demo, I guess. Yeah, 21st century version of the self-reproducing automata, David Kiersey. Yeah, absolutely. Not quite there yet, but the goal for January 3rd, the goal for Blastoff is to be there, to arguably at least obey the rules of what make the von Neumann universal automata key. That it has the code, carries its own code that gets used in two different ways, both as an actual program to execute, to perform the construction of a new abode, and as passive data to get copied into the new abode once it's done. My goal is to do all of those things. And the von Neumann original self-reproducing automata, the universal constructor, it didn't have evolution in it. You had to hack it and go in and do it. It was completely deterministic. And my goal is to make the diamond sequencer, the diamond grid ancestor code robust enough that mostly it won't evolve either. But we can't guarantee that, of course, right? Because anything could happen. There could be some weird race condition. I'm just concerned that I only have one ancestor, so until it's reproduced a couple of times, I really don't want the reproduction to mess up. I want the reproduction to be pretty high probability. Well, and these things are going to be fairly sizable. I'm not sure how big they're going to be, but they're going to be fairly sizable. And I want them to be able to have a bunch on the T2 tile grid, the 3 lotuses we've got. And so we'll see. But I think to David's point that this is going to be the first von Neumann self-reproducing automata for a best effort for robust systems, fallible systems in the history of the universe, or at least in the history of life on Earth, if we're talking about the von Neumann machine. Anyway, okay. Still got our thing going there, and actually it looks like the rendering is almost done, because I did keep it fairly short. Well, should we wrap it up? And thanks again, folks, for coming in live. And like I said, I mean, I'm going to be trying to, the Discord has been very quiet the last few weeks, and I'm sorry about that. I don't exactly know how to play Discord, but I'm going to try to check in the little hash progress channel and just do anything, just grumble or say yay or put up a screenshot or something from so on and so forth. So as they say, if you're craving more T2 content, I guess everybody has like a zillion Discords, and so the just question of whether you let the server give you notifications or not. And given that the T2 Tile project server is so quiet, I think we can afford to leave notifications on for it. Okay, I'm going to stop there, and I'll see you on the other side. Hope everybody is doing okay. Yeah.